Hello, my dear friends. Welcome to Toppscholars. Today we'll be discussing about states and classification of matter. So friends, let's first start with the general classification of matter. Now friends, everything that is present around us is said to be matter, which means that matter is anything which has mass, occupies space, and we can perceive it through our senses. All this matter can be broadly classified into two categories, that is, living matter and non-living matter. Living matter includes plants and animals, that is, matter which is obtained from plants and animals, whereas non-living matter can be broadly classified into two categories, that is, natural non-living matter and man-made non-living matter. Now, if I talk about natural living matter, that is, natural non-living matter, I can have some examples such as soil, metal. Soil is used for making earthen pots, right? Whereas metals are used for making utensils, ornaments. In the similar way, man-made matter is matter which is artificially produced. Now friends, matter can also be classified depending upon its properties. That is, matter can be classified based upon its physical properties and chemical properties. Now, based on the physical properties, matter can be classified into solid state, liquid state, and gaseous state. Whereas, on the basis of chemical properties, matter can be classified into pure substances and impure substances, which are called as mixtures. These pure substances can broadly classified into elements and compounds, whereas mixtures can be classified into homogeneous mixtures and heterogeneous mixtures. So friends, let's first discuss about the classification of matter based on the physical properties. Now, as I said, based upon the physical property, we can classify matter into three states, right? That is solid, liquid, and gas. So now let's one by one discuss each of the properties of solids, liquids, and gases. Now, if I talk about solids, friends, solids generally have a definite shape and definite volume, right? Whereas, what about liquids? Liquids do not have a definite shape, right? But they have a definite volume. Liquids take the shape of the container in which they are poured. But what about gases? Do gases have any shape? No, gases do not have a definite shape. What about volume? Gases do not have a definite volume, which means that gases simply occupy all the space that is available to them, right? Now, if I talk about the particles that make up these three states, that is, if I talk about the particles which make up the solid substance, right? In the solid substance, the particles are tightly packed to each other, right? Which means that they are very closely bounded to each other. Whereas in case of liquids, the particles are less tightly packed. That is, there is a little space between these particles. Whereas in gases, the particles are free to move here and there, which means that there is no packing in case of gases. Now, since we said that in solids, particles are tightly packed, right? Since the particles are tightly packed, the intermolecular force of attraction between the particles is very, very, very strong. That is the reason why you cannot easily break solid particles, right? You need to apply some force to break these solid particles because the intermolecular force of attraction between the particle is very, very strong. What about liquids? We said that in liquids, the particles are less tightly packed, which means that there are some spaces in between, right? Which means that the intermolecular force of attraction is weak, right? And that is the reason why liquids do not have a definite shape. But what about gases? We said that gases neither have definite shape nor they have a definite volume. And they are free to move here and there, right? That means particles of gas can easily move here and there. There is no packing. This is because the intermolecular force of attraction is very, very weak, right? Now, we said that in solids, the particles are tightly packed. Intermolecular force of attraction is very strong. And thereby you can see that the intermolecular space is almost negligible, right? The particles are so tightly packed to each other that you can see that there is no space in between the particles. Whereas if you look at the liquids, in liquids, the particles are less tightly packed, right? And so you can see that there is some space, right, in between the particles, which means that intermolecular space in liquids is more as compared to that in solids. Now let's move on to gases. Carefully look at gases. The particles are freely moving here and there. And there is so much space in between, right? Which means that intermolecular space in case of gases is largest as compared to liquids and solids. And that is the reason why the particles of gases are free to move here and there, and therefore gases do not have a definite shape nor a definite volume. Now here we discussed about how matter is classified based on the physical properties, right? That is solids, liquids and gases, right? To learn more about this topic, download Toppscholars app.